Welcome back, guys. So, as many of you have been waiting for, finally we are there. Um, we're gonna look at trigonometric integrals. I know during my days, this topic posed a lot of problem for a lot of students. It's very easy to understand. Again, you have to understand the basic rules. You have to know what you're supposed to do when you see sine to an odd power, sine to an even power, cosine to an odd power, and an even power, anything like that. So what we're gonna do is we're gonna start talking about odd powers of sine. So in trigonometry integrals, you find sine to a certain power, but in this case, let's say odd powers of sine. Of sine x. So what we're gonna do here is, in this case, if you see sine to a certain power of, let's say, m, where m is odd. And m is greater or equal to 1. So when you see something like that, what you have to do is you have to split off one of the powers and use the trigonometry function. So when you see something like that, you split off one of the powers. And use the trigonometry function sine x is equal to 1 minus cosine x. Sine s squared is equal to 1 minus cosine s squared. So this is going to be very helpful. You must memorize this. You must have this in your mind if you want to tackle any questions involving trigonometric integrals, which has sine or cosine in it. So let's put some example here. Very quick one. So we've been asked to evaluate. Sine to the third dx. The first thing which should come into our mind is we look at the powers. The power here is 3. Is greater than or equal to 1. And 3 is odd. What does the rule say? Split off one of the powers, and use this trigonometry equation. So we're going to split off one of the powers. We're going to have square here, x multiplied by sine x dx. But we know this guy here, which is the general formula, is equal to 1 minus cosine x. So what we're going to do is we're just going to substitute for that. So we're going to have 1 minus cosine squared x multiplied by sine x dx. Now we're going to then use our simple substitution. We know that if you do substitute for cosine, if you do differentiate cosine, it gives us minus sine, and we have sine over here. So that should give us a clue that u substitution will work here. So we will let our u to be equal to cosine of x. Our du will be equal to minus sine of x dx. So you see, there we made the right substitution, so we found this guy here to be that. Even though this minus sign, it doesn't have the minus sign, but it doesn't matter, we can just bring it in front. So we go ahead and do this u substitution. We have 1 minus u squared. Remember, we let u to be equal to this, so cosine squared is u squared. Then we bring our du to replace that. So we have du, we have our minus here, so we bring it up in front. So now this is like any other integrals that we've done. You just have to integrate these guys, and that will basically give us u here minus u squared, u to the third over 3 plus c. All you have to do now is just leave our answer in terms of x, because we were given the question in terms of x. So what we're going to do is we substitute back. We bring back our cosine. So whenever we see u, we put cosine x. So u cosine x minus u to the third, which is cosine to the third x over 3 plus c. So yes, we have solved the problem. We have used our knowledge that we know we have in integration by powers. Integration using u substitution to solve this problem. So whenever you see any odd powers of sine, and which is greater than, where that power is greater than or equal to 1, remember you can just split off 1 and use the trigonometric substitution right here. The function right there, which is sine squared x is equal to 1 minus cosine squared x to solve the problem. I'm going to work more example on this, so I'll see you in my next video. Thanks.